Did you just say you've started recording? Yes. Okay.
Yeah. All right. Awesome. Okay, we can go ahead and start then. I think Victor and Sophie are in the shop. If you wanna take a look at the nose cone, can we move the camera to the tip of the rocket so we can see the nose cone? And then Victor is our head of manufacturing, so he can maybe talk a little bit more about how the build is going for each specific sub team. And then we have majority of our sub team leads here. If there are any more like design specific questions, we can answer those.
Okay.
Yeah, sure. How do I flip the camera around? There you go. All right, so we have, I'll start from the top. So we have the tip of the nose cone or the nose tip. Um,
Okay.
it's it's recently being machined.
Hang
Um,
on, hang on just a second. I am
yes.
looking for how I can change my view so I can just be looking at you.
Okay.
And I'm I'm used to seeing a button that will give me a speaker view, and I'm not seeing that now.
In the top right-hand corner for me, next to the recording button, for me, there's a button that says view, and you can choose it from there. I'm not sure.
Yeah, and what I've got there instead is a leave meeting button, which I do not want to press.
Yeah. Are you able to right click and pin his video? Does that work?
Maybe just click my video and then it will just pop up if that's the case.
Okay. Um, found speaker view. It was not how I expected. Okay, so let's start over again. You were showing me the tip of the nose cone.
Yeah. So it's actually 90% done. I just have to face part off this section. This was used to hold the entire piece in a chuck.
Hmm.
So this will be part off by tomorrow, I think. Oh, because we're yet to machine the nut that holds it in, that jams it in the nose cone. But if
Okay.
you see it here, um,
Right.
that will be kind of the nose cone assembly. And
Hmm.
the coupler and the nose cone are epoxy together. Um,
Okay.
and this thing will be installed later, in there, right?
I'm
Uh,
curious. Your report mentioned the nose cone was made using a compression molding technique that you guys developed. What?
yes, I'll have
Can
the
you tell me
mold
a
here.
little bit about that?
Yeah, so might be a little hard to imagine, but so this would be what's on the outside,
Okay.
right? So and this was the inside mold. However, because there was some we didn't do enough sanding to make the surface smooth, we had to basically melt the whole piece to extract it.
Okay.
So essentially how it works is that so here's the nose cone, the inner mold and the outer mold. So the
Hmm.
nose cone would sit over the inner mold.
Hmm.
That gives that gives you the shape of the nose cone and the
Right.
profile of it. And then the exterior mold, which you can see it's a two-piece mold that's clamped together,
Hmm.
would slide over it and provide it the compression it needs to get rid of any extra air bubbles or extra epoxy. And everything will just kind of flow out and flow down towards the bottom of the nose cone due to gravity. And outcomes is a really clean nose cone with no visible voids or unevenness on the surface.
Okay. That description, it wasn't clear to me where the compression came in. Did you like pressurize the inner mold or something?
No, so the entire compression came from the ever so slightly undersized outer mold. So
Okay.
the gap between the inner mode and outer mode, I think is ever so slightly thinner than what the actual thickness of the nose cone is,
Hmm.
or the desired thickness of the nose cone. And obviously, when you lay it up, when you do wet layup, it's not a perfect,
Right.
compression between layers. So that difference in thickness from the initial layup to the final, dimension is all we need to make it sufficiently
Okay.
strong for the nose cone.
Okay. I think I see what you're saying.
Yes. And then the reason why we chose this is just because it's really fast to print. So the two molds, the inner and the outer molds combined, would take 20 hours on a Prusa printer.
Mhm.
And you can easily, redo the inner or the outer mold in about 10 hours or overnight.
Right.
And you don't have any, you don't need to machine anything, and the cost is really nothing.
Right. And you just have a seam to uh, sand away.
Yeah, like just give it a rough sanding to get rid of the
Yeah.
seam and smooth out the surface a little bit. Yep.
Very nice.
And what you don't see here, I just want to mention, is on the bottom side of the inner mold, we also have like a extended section about 1 to 2 inch for the
Okay.
coupler to sit in. So that will be an
Okay.
added straight wall section. So the coupler can, and then it will be initially kind of glued to the bottom of the inner mold to
Hmm.
form like a continuous piece,
Hmm.
and that will be also, and then that will kind of mold out the where the coupler is, and
Right.
that's shrink wrapped, and then shrink wrap will provide the compression needed for that to cure. Because it's a straight wall, we don't want to slide anything directly over it, and as it
Right.
might ruin some geometry.
Right. Okay.
Any questions?
No.
Perfect. Okay, I'll keep that out of the way. Okay, so the body tube is basically the same tube as the motor tube. Nothing special about them, just wet layup and over a aluminum mandrel. And we're
Hmm.
using Mylar and mold release as the kind of the release agent, and to prevent the epoxy from bonding to the aluminum tube.
Right.
So nothing really special about that. It's just with the addition of Mylar, it really makes our life easier when we're trying to pull the tube off of the mandrel.
Right. Well, you need something for a mold release.
Sorry?
I said you need something for a mold release.
Yeah,
That's
exactly. And then on the exterior surface, to keep it really consistent, we what we do is we put peel ply around it, and then we use shrink tape to provide the compression, and that
okay.
gives us a really smooth and even surface if we do the shrink wrap in the right way, which
Hmm.
we seem to have figured out.
Hmm.
And for the inner surface of a tube, let me find an example of a tube. Um, Here. So using the Mylar and method with the mold release wax, the inner surface is really shiny and has a really good
Yeah.
tolerance. So this was meant to be a 3-inch motor tube. What we measured is I think 3.006 or 8, so less than 10th out of tolerance on a composite part using no machinery, which I think it's really acceptable.
Hmm. Oh yeah, that's very nice.
Yeah. And then, so that's in general how the tubes are made, including the body tube and the motor tube. And I think I can move to the bulkheads next. So for the internal structures, we have 3 bulkheads, bottom, middle, and top. These are the exact same part as each other and is manufactured using water jet. So we have a
Okay.
1/2 inch thick stock that we use. The reason for half inch is because last year we experienced issue with shaft collar lighting due to the high forces off the launch. So this year we're trying to drill holes into
Okay.
the bulkhead and into the internal rod. So we have a physical mechanical fastening between the rod and the bulkhead. So hopefully there will be no more sliding, and
Right.
everything in the bulkhead and the internal structure has, I believe, at least a 1.5 safety factor. So we have a good we have room to spare should there be any problems.
Hmm.
And propulsion bulkhead, same thing. Just no holes. But only this is cut off or phased off, part off of the round stock that we machined the outside diameter to be smaller than the coupler, so it's able to be fitted in the motor once the coupler is installed. And there's just a bulkhead, sorry, a 3/16 tapped hole for the eye bolt.
3/16?
3/8, sorry, 3/8
Okay.
16. Yeah, sorry, my bad. And as for the
I'm
sorry,
curious.
go ahead. Yes.
The other three bulkheads you were using screws to anchor. Are you doing that with this one as well?
No, so this propulsion bulkhead kind of uh gets held in position by the inner motor by the motor tube. So
Okay.
between the propulsion bulkhead and the thrust plate down below, it kind of squeezes or locates the motor where it needs to be with the help from the internal or the motor tube. Sorry.
Okay.
And then just to mention, these materials are all 6061 aluminum just to keep the weight down a little bit.
Hmm.
And thrust plate was the exact same design as last year. In fact, this is the exact same part that we plan to use because it worked well and we haven't changed the design much this year. Where our goal for this year was to optimize the manufacturing process and to improve the tolerance and quality, which we definitely did. Um, so that's why some of the parts have really similar or slightly optimized design, while the other parts remain basically unchanged. Because kind of to conform with our goal or target for this year.
Right.
So that is, and also the fins. So the fins are currently being worked on. But I do have like a test sample here that we cut out some tensile testing pieces out of. This one is overly thick. I think about 6 millimeter. The real fin we use is 3 millimeter, and it's like a composite of twill and forged carbon. So we have 5 layers of forged carbon with 4 layers of twill sandwiched in between. The reason why we went with forged is because it has a good omnidirectional strength characteristic, and to strengthen the fin to help it fight against fluttering, we have
Hmm.
twill running kind of parallel and perpendicular to the direction of the travel of the rocket.
Um, how thick a fin did you use last year?
I think last year it was 3 millimeter, but it was optimized to a lesser degree where we have less layers of twill inside.
Okay, a 3 millimeter just sounds a little thin.
Yeah, we did our calculation, and plus we're using tip to tip layup, so it should provide us with enough room
Okay.
for spare.
Yeah. Speaking of the calculation, I remember in your report it looked like you were using the old Apogee calculation, Apogee Picaflight newsletter calculation, um, which has that factor of a square root 2 error.
So that will be a question for someone else. So I'll pass on the mic to someone else.
Is that Mihan? Is that your team that did that, or was that airframe?
That will
No,
be close to airframe, I think.
Okay.
yeah.
Fortunately, we don't have airframe. I'm sure they couldn't make it because they're in another time zone. I
Okay.
can pass on your concerns to them about the apogee. We can get back to you with a more updated apogee calculation if that's
Okay.
okay with you.
Yeah, it was a little embarrassing to find out that for like a decade, everybody has been using the wrong formula. Um, but the rockets have generally been surviving. Anyway, back to this rocket. You were discussing the fins.
Sorry, are we still on the fin topic?
Well, no, you guys will be getting back to me on that calculation, and
Okay, cool.
so
Yeah, unfortunately, I did not do much designing work this year, so I couldn't answer that question. Sorry.
mhm. Let's see. Did we just lose Victor?
Yeah, that was me. Sorry. So yeah, I don't think any of our airframe members or team leads are here.
Okay.
So that will be
One thing that's concerning, of course, is that you are a ways from having a completed rocket. Uh, how much time do you think it's going to take to finish all this?
I think I think in the next 3 days it will be done. Like we have all the parts machine verified in dimensions. So all to do right now is just to basically epoxy everything in place.
Okay.
So we spent a lot of time and energy in making sure the parts are right before we did anything to assemble them. Because we do have a bit of a issue with file management this year because GrabCAD was shut down. So it was kind of hard for us to, sync files together, especially CAD files.
Hmm.
So with for this reason, we took a more conservative approach to kind of
Okay.
verifying and checking everything.
Okay. Um, I'm curious to go back and look at uh, more of the design, and I've got the org file up here, and I'm not sure I fully understand sort of how everything fits together. Um, I'm seeing your nose cone, then a parachute, then your payload bay, then your avionics bay. So is there like is there wiring from the avionics bay up to the bulkhead just past the parachute to fire that ejection charge?
I
Mihan?
can answer that question. Yeah.
Yeah.
So you said we're talking about the parachute in the nose cone.
Right.
Yeah, it doesn't go past the parachute. There's a bulkhead that would be just below the parachute.
Right.
So yeah, our charges would be on that bulkhead.
Okay.
But yes, it would go up through the payload, the
Okay.
wiring.
Pull up the CAD if you want like a visual. Um,
Sure.
okay. Just give me a couple minutes to get that loaded.
While she's loading that, Joe, I just want to let you know I have to drop out. I've got to be up the road in about 10 minutes and I will be out of cell coverage.
Okay.
John and Sabrina, I see, are both in the call. So the three of us are kind of a fly of record team. So
Okay.
there's enough Canadian teams that we just kind of signed up for all of them and
Oh,
we
very
swap.
nice.
So we're
Okay.
tag teaming. So I wanted to let you know before I dropped out.
Okay. Well, thank you.
Okay.
And thank you for the time you were able to spend.
Yes. Take care.
You too. Um, and just an almost administrative question about your parachutes. Do you actually have them?
Yeah. So we're
Okay.
planning to reuse the same parachutes as last year. We had very minimal I guess, damage to it, which we properly patched up. So yeah, we're planning to use the same ones.
Okay. And also, do you actually have your motor?
We don't have it physically because we can't bring it across the border, but we have it ordered and it will be there when we get there.
Your supplier has verified they actually have it.
That's a Lux question, but I'm quite sure that they like we were very ahead of the ball because we know about the shortages this year. So
Right.
again, I guess that's a question for Lux, but that is my impression.
Yeah,
Okay.
I can confirm with Laksh, who's our propulsion lead, who's not here, but we did order it many
Quite
months ago.
early.
So
Yeah.
Okay. Yeah, and I asked because there's real problems right now with both. Well, it's Rocket Man parachutes that are having troubles, and then the Cicerone motors. So
Yeah.
okay, so you're in good shape there.
What is the motor?
Yeah. I don't know what the spec is.
I can answer that
Yeah.
in 1 second. Pull up- let me pull up the report. I'll you answer that for you. Um, the motor is a I'm trying to take my time as I find this information.
And this is actually your report. It says it's going to be an M1590
That
with
is actually incorrect information. I think our is this our final report you're referencing or our like our third like our like submissions?
report 2.
Okay. It's been updated. It hasn't necessarily been updated, but I think there was a miscommunication and the wrong motor was put in there. Our final report has a correct motor, and that's the M 3700.
Okay. And
But
actually, that was something I'm surprised I didn't notice it before, that the designation you had in there was an M1590 with an average thrust of 3710.
yeah, I think there's just miscommunication there. But our final report that we submitted on Friday does have the correct.
Okay, and your ORC also file also has the 3700.
It should, our most recent one. I'm not sure which one you have. But I can send you what I know
It's
is the most recent version. But
it's the one from your report too, which
it we might have
corresponds to
had
what you just told me.
okay. Well, that's perfect. We might have had some slight changes to it since then. But the motor should be the same. I have the CAD pulled up here. I will share my screen so you can get a better idea of like a visual of the rocket. I apologize, I don't have my mouse on me, so this might be a little hard to get the exact angle you're looking for.
Okay.
So it's loading. Also, it might just take a while. But as it's loading, you can kind of already get a visual and see that we have the. Can you see my screen first of all? Is it coming through properly? My internet connection might be a little spotty.
Yeah,
Okay.
I can see it.
Okay, so as it's loading, you can already see that like we have the we have the bulkheads here, and this was our top bulkhead that Mihan was talking about, and the parachute is going to sit in the bay here, and the bulkheads would this is what the wire is going to this bulkhead and not going up through
Oh,
the nose.
perfect.
Yeah.
Yeah. The funny thing is that the Open Rocket 3D view is pretty much easier to see than the SolidWorks.
Is there any other part of the SolidWorks you'd want me to show you while I have it up?
I don't think so. I think I'm understanding what's happening here.
All right, awesome. I will stop sharing.
So you're using
So
black powder ejection charges.
Sorry, what was the question?
You're using black powder ejection charges.
Yep. So we're using four, two primary and two backup. Uh, Obviously one for main, one for drogue, and then a primary and backup for each.
And the drogue is in the middle of the rocket and the
Yep.
main is at the end.
Yeah, and the nose cone.
And the altimeters are what?
So we have the Easy Mini, and then we also have a SRAD version that will be the backup.
Okay.
That reminds me, you did a good job of explaining how you derived the black powder charge, assuming I think it was 8 shear pins.
Yeah, we've
Uh,
actually since lowered that because we realized that eight is one, it's overkill and it's very hard to align. The reason why we had eight in the past is because we had an issue where our bay was too small, so we were worried that pins would actually pop out by the actual parachute. But this year we redesigned our rocket, of course, so we made our bay of bigger, so we don't have won't have the issue. So therefore, we want to reduce the amount of pins, and we did redo the calculations for black powder based on that, and it wasn't a huge difference, but we did redo that.
okay,
So how
let's
many
see.
shear pins are you using?
I forgot what was the exact number in the most recent one. I want to say it was six or was it four? It should be in the CAD.
You don't send us the files, unfortunately. We don't get to see them, unfortunately. We
Yeah,
would like to
Julie.
have seen them.
Yeah,
Yeah,
we should be sharing that with you.
sorry, it would be four. I have the drawing here for the
Okay.
bulkheads. It
Yeah,
is
Okay,
four per
that's what I
bulkhead.
remember from my
Yep.
calc.
See, I'm trying to remember if I had any questions uh, about your avionics. I'm not remembering anything that struck me as troubling. Um, I'm looking over at your report now.
Do you have radio communications back to the ground to track?
Yes, we do. So from the featherweight, we get the general location of it, but then also from our SRADs system, we have kind of a more I guess more advanced tracking where we can see different things like the orientation of the rocket and such. I'm not the avionics lead, so I don't want to oversell it, but yeah, we do have radio communications in two channels for redundancy.
Have you put them all together and tested them?
Yeah. So, well, one thing we actually were worried about that we tested for is we wanted to make sure that our charges won't go off at the same time because we have one SRAD and one COTS. So, one test that we did is we put those together in a vacuum chamber just to ensure that our delays were set properly and that both charges won't go off at the same time. As far as the GPS testing, we also did pretty extensive testing on both the COTS version and the SRAD version, which should be documented in one of the reports.
Yeah,
What,
you were talking about doing a fox and hound test, which I think you're the
Yeah,
first
we
team
did.
I've ever seen actually do that.
It's a little bit of fun too, you know.
Yeah,
can I make a suggestion that you test assembling that avionics quite a bit, because usually the teams have trouble getting their avionics going when they're out in the field assembling, and it causes many, many delays.
Yeah, absolutely. That's a good idea. And we do plan to have like a full assembly, except of course the motor, before we ship it for that reason.
well, and something else that causes a lot of delays is make sure well before you come down to the launch pads that you fire up the GPS and get a lock,
Yeah, yeah,
because the GPS sort of assumes that it's where it was before and works from there and modifies the lock to get to its real location. And you know, you're several thousand miles away right now, and so that will take it a while the first time
okay.
you start it up.
That's some great advice. I'll make sure I write that down for before we go.
How long are the shot cords, and what are the shot cords?
They're both 25 feet. The what they're made of is, I think it's Kevlar and something else mixed. I think it's mostly Kevlar. I wonder if I have it somewhere.
Yeah, now I'm curious. I remember it as just being Kevlar, and I've never heard of a Kevlar
I think it
blend.
might. No, I'm thinking the blend is actually. I messed my words up. The blend is the deployment bags, which are Kevlar Nomex. The shock cord should just be Kevlar.
Okay,
And you're comfortable with 25 feet?
Yeah. Are you not? Is there any concern?
It's on the shorter side.
We did,
Your
yeah.
rocket's what, 10 feet long? Almost 10 feet long?
Yeah, I think it's, I know the general rule should be 3 times. I think we're about 2 point, I think we're just under 10, so it should be somewhere about like 2.6, 2.7 times.
How big is your main chute?
12 feet.
And so we just had an incident where there was a 12-foot chute, and the tie-in point was shorter than the length of the shroud lines. So
But yeah,
the chute was in the nose cone, and the shroud line reached its limit, or not the shroud line, the shock cord reached its limit before the shroud lines they actually pulled out, but left the chute in. So the shroud lines, there was nothing pulling out the chute.
yeah.
So make sure your shroud lines aren't gonna. There's ways of mitigating that. One is have the shroud line shorter. Also, um, you can fold the parachute such that the shroud lines won't come out without the parachute.
Yeah,
It'll come out
okay.
at the same time. So with a big chute like that, make sure your shroud lines will come out
Yeah, okay.
as the shock cord extends.
That's also something that,
A lot of the
yeah,
nose.
yeah, okay. I got what you mean. Yeah, I think one of the things we really want to perfect this year is our packing techniques, because I think last year we didn't do it perfectly, and that might have been some of the issues why we had a harder landing than we wanted. So we definitely will put good time into making sure our packing is done right.
Okay.
And this is sort of wandering a little ways from safety for this year, but I'm a little bit surprised to see the number of teams who are rigging that main chute the way you are, where it's in the nose cone, and you're sort of depending on inertia or something to get things separated.
Yeah,
I'm used to, and the way I do it is, there's a solid bulkhead at the end of the nose cone, and the parachute is aft of that, so that the charge, blows all the laundry out into the air,
yeah,
and
yeah,
you're not relying on anything to pull it out from there.
yeah.
Um, I haven't looked at this as carefully before now. What is your payload this time?
Yeah, I can speak to the payload. So we're aiming to launch a technological demonstration payload, but we're also developing a boilerplate payload at the same time so that we always have it as a backup if we need it based on timeline and for future years. Our technical payload is fully designed, but just since the rest of the rocket's first priority, we haven't had time yet to do the metal manufacturing for it. Our plan is to keep working towards the goal of finishing this, but if there's not time, we are going to use our non-functional boilerplate payload, which is finished and at 8.8 pounds. But the functional payload's goal is to launch a camera in the payload bay to collect video footage of our flight for increased insight into the flight path, but mainly for marketing and sponsorship, promotional material, and community engagement within our school.
Okay.
We can go into more depth about the electronics and the structure of it if you want.
No, that question was more for curiosity, because it does not get ejected. It comes down with the rocket.
Correct. It's in the rocket the whole time.
Yeah. I just realized I didn't take much of a look at the avionics bay as we went through the build. What's its status? What's it looking like right now?
So it's designed. It was actually the avionics bay was not in the CAD because they use another CADing software. So but it is fully designed, and I have the design of it. I'm not sure about the build. Maybe Victor can speak more on if avionics is building or on their progress. If unfortunately we also don't have an avionics team member in here. But Victor, if you're around, can you speak to the avionics bay and how progress is on that? I don't know if he knows we're speaking to him.
I think the CAD is complete.
Yeah, the CAD is fully complete. I have the CAD, but it's more, I think, the build progress we want to know now.
Right.
I think it will be 3D printed. And then there will be um I'm not exactly sure, but I think there will be an acrylic plate in the center holding up the parts. Similar as last year.
Yeah, I don't think there was much change from last year. Um,
I'm just
Okay.
confused. I thought when I asked about the avionics that it has been tested, but you just the components have been tested.
Yeah, so the boards have been tested, but I guess the not assembled into the Avbay, which of course it will add some interference and such, which is why it's important to test it like that. But yeah, they've been tested just as the boards.
Invariably, teams lose a lot of time at the site because they haven't completely completed their avionics bay and haven't been comfortable assembling it and setting it up. I just advise you to do lots of playing with that.
Well, a general comment I would make is that I hate to phrase it this way, but you guys are kind of running behind. Is what we're hoping to see in this video is the actual build of the rocket and what the rocket looks like assembled. And you guys are ways from having a functional rocket, which is why I asked about your timeline, and 3 days seems very optimistic.
Yeah, unfortunately, we our exam season was like all of April, so April was a bit of a standstill, which is why we're in this time frame. But we do have a lot of people who are going into the shop pretty frequently. Um, I don't know if Victor wants to talk more about his timeline, because he is in the shop and does a lot of manufacturing. But we do have our ship day is for early June, and we are confident that we'll get it done by then.
Yeah, a little bit of
Yeah.
background on this. So sorry. It's just we have a like a delayed design timeline, so everything kind of went downhill from there. And April, as Julia mentioned, was the exam season, so kind of people are busy and uh people on co-op or on internship, so we don't really have the time to build it. I think the final design was confirmed end of February. So given the amount of time manufacturing had, I think the progress was kind of on par uh with what I wanted. So maybe next year.
And I think I just lost you. I can't.
Yeah, I think he cut off, but I think the point he was trying to make was that this year was like all about optimization, and obviously we still have optimization to do with our design timeline, which is something we are constantly working towards, and hopefully we'll improve next year. This is only our third rocket, so every year
Okay.
we're learning. But yeah, we are definitely not exactly where we want it to be, but we are confident that we will be there.
Yeah, the biggest thing is just to try to make sure the design starts before hiring finished, which is usually around end of October or mid October. So I think
Right.
last year that's what happened, and this year maybe I think we'll start the design right on September, and then till probably December.
Okay. And looking here, I just realized one thing I hadn't asked about. What are you doing for motor retention?
Like how it's staying in the rocket.
Yes.
Okay. I'm not the lead. Our lead is not here, but I did just write about this in the report. So I will tell you what I know. And if you have more in-depth questions, I can pass them along and get some answers back to you. So our motor is actually I can probably share my screen. That will probably help me a little bit.
Okay.
So our motor is this is our motor tube at the bottom here, obviously.
Mm-hmm.
And I just hid the tube, but you can see here we have our internal motor tube right here, and this is where our motor slots into. This is the propulsion bulkhead at the top, which Victor showed a little while ago.
Oh, okay.
And that that threaded hole in the middle is for this eye bolt, which will thread into the motor tube. Our centering rings to keep our inner motor tube in place. And then at the bottom we have our, oh my goodness, sorry, lack of a mouse.
Poof.
Yeah. And then at the bottom we have our thrust plate, which Victor also showed, and that has the
Right.
push up against the bottom of the rocket, and then our fins that are actually going to our structure as well. And Victor can probably speak to more of the manufacturing if you have more questions about like the epoxy and stuff. But that's the rough overview of the design and how it's held in.
Right, but yeah, the answer to the actual question is you're using the 3/8 bolt up at the top.
Yeah, that's correct. Yeah.
How are you keeping the eye bolt from spinning when the drogue comes out? How do you keep it from unscrewing? Are you putting a pin through it, or
In the past, we've just used Loctite, but
um,
yeah, that's just the way we've done it in the past, to be completely honest.
if you have the opportunity to drill a hole and put a pin through the rod and the eye bolt just to keep it from turning at all.
Well,
Loctite.
is it an eye bolt or an eye nut and a rod?
So it is the eye bolt directly
Okay.
threaded into the motor. However, the propulsion bulkhead is also threaded, so that acts as a jam nut.
Mhm.
That together with the Loctite should keep everything in place, and there's probably a really small percentage of chance that it can come out in that environment.
Yeah. So yeah, the pin or like a pin, it wouldn't be helpful there, but a safety wire wouldn't hurt.
Yep, for sure. We'll take that into account. Um, it's just where do you usually thread the safety wire? Is it through the eye bolt?
Oh, put a little screw off to the side,
In your
and
Okay.
bulkhead.
then yeah, in your bulkhead,
Mm-hmm.
and then put some baling wire um, through the eye bolt, and then around the other
Got it.
screw.
Got it. Got it.
And I say a screw, but like some
Mm-hmm.
kind of even a wimpy eye bolt
Mm-hmm.
would be
Mm-hmm.
a good way to do
Yep.
it.
Yep, for sure. Okay. I'll note that down. Thank you.
And I'm trying to think if
Any
I
more
have any other
questions?
questions, and um, nothing is really coming to mind. Uh, it looks like your design is very solid and very sound. Um, it's just your time that, well, I've said it enough times. I don't need to say it again.
Any comments on kind of sort of the manufacturing techniques that we use on this rocket and compare this to other teams that you've seen?
Well, uh, your manufacturing looks really good actually. Um, it becomes one of these things where I would ask why that there's really high quality fiberglass you can buy, and if you had oodles of spare time, then doing your own layup uh, would make sense. Um, but having said that, the uh, job you've done on that manufacturing, looks like professional quality work. So it's
Yeah.
very very well done.
Thank you. Yeah, I think it's just because we are a new team, and we do want to have as much knowledge as possible. Kind of, I feel like we just have to do like a development process to make sure that we have the ability to do it should we want to do it.
Mm-hmm.
And let's say if down the line we decide to shift our focus, then we still have this knowledge in the bank, and we can buy a tube. That's pretty easy to do.
Yeah. Yeah, I laid up one fiberglass tube once many years ago, and I learned my lesson. It came out awful. It did not look anything like yours, and I have not done it since.
Yeah, we that was us last year. So we kind of scrapped 4 or 5 tubes before we reach usable level. So yeah, it is a bit of a learning, but
I might make another suggestion. The work you've done is good, but in the you're running short of time, and I would spend the time assembling and practicing assembling rather than optimizing everything. Just use standard processes, standard designs, and get it built.
yep, for sure. That is definitely something to do next year. To push the deadline forward by at least a
Right.
month or two.
Okay, well,
Yeah, so I just want to say thank you for the feedback.
that's what we're here for.
Yes, thank you for your time and all the emails as well.
And thank you for your time as well. I look forward to seeing you at Spaceport.
Yes, us too. I'll get back to you. I'll be in touch about the updated apogee calculations. I think that was all the information you wanted, but if you think of anything else, let me know and I will make sure to use that information.
And I guess where we go from here is you please send me a link to the recording, and you're supposed to send it to Ezra as well.
Yes.
And please do that, and I think we're set.
All right.
All right, thank you.
Thank you.
Thank you.
Have a good
Thanks,
night.
Joe.
You too.
I'll see you